Hello everyone, so welcome to our video lecture. In last lecture we have started with enantiomers. We have studied about RS configuration. Okay, so let's continue with how to check the RS configuration in different cases. RS configurations. So students, we have studied the shortcut formula SARC, S-A-R-C, right? For anti-clockwise it is S, for clockwise it is R. But this condition is applicable only when the lowest priority group lies at vertical line. And if it lies at horizontal line, then S becomes R and R becomes S. Clear? Now let's check that point which I had told to be continued in the next lecture. That was about hypothetical bond breaking rule. So let's see with the help of some examples. H CH2 CH3. Suppose this is CH double bond CH2 and it is C triple bond CH. Now dear students, if you see this example, so from this chiral center, see this is your chiral center having hydrogen, this is ethyl part, ethanyl part and ethanyl part. So all the three groups are different, ethanyl, ethanyl and ethyl. So in this case what to do? Suppose if I move from this carbon towards this carbon, 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 here also carbon, carbon. So I cannot say which one will be R, which one will be S. So in this case, see this is a chiral center having four different groups. Okay, so in such cases we need to understand hypothetical bond breaking rule. Okay, so what we need to do here, just understand, suppose you are having C triple bond CH, you can see here C triple bond CH. Okay, in this way, here see this carbon is connected with triple bonded carbon. Okay, means I can say that this carbon is hypothetically connected with three other carbon atoms. So one is already there, just connect three, so one is there, two other hypothetically. Okay, now I will come to this carbon. Now this is also connected with triple bonded carbon, so this carbon is connected with three carbon, so one is already there and two are hypothetical. So this C triple bond CH is hypothetically understood as this part. Clear? Okay, now this is one form. Now let's see what about this one, CH double bond CH2, CH double bond CH2. First of all you try by yourself. Okay, so here you can see this CH single bond CH2. Now first of all come to this one, this carbon is connected with double bond, so one is already there. Now this carbon is hypothetically connected with two carbon atoms, one is there, another is here. Now this carbon is also connected with two other carbon, one is already there, one you have to connect. Okay, so now students, if you see this position, hypothetical part, this part and this part. Okay, so what you can say, from this carbon it is the fourth priority. Okay, now first one, this carbon is connected with three carbons, one this side and two hypothetical. See this carbon connected with 1, 2 and 3, this is connected with only one carbon and two hydrogen, and this is connected with, this carbon is connected with two carbon atoms, this carbon is connected with one carbon here and one carbon hypothetically. So this will be your first priority, second priority, third priority and this fourth one. Okay, clear to everyone? What you have to do is, if there will be any multiple bond, it may be double bond or triple bond, in both the cases you just write one bond and then connect those atoms in both the sides. If you are having C double bond O, okay, then make C single bond O, connect oxygen with one more carbon and connect this carbon with one more oxygen. We will see with further examples. Now we have made the priority. We can see here it is what? It is anti-clockwise using the rule S conformer configuration, and it is fourth group here in vertical line, so it is S configuration. Clear to everyone? Now, this compound is optically active, okay, and no POS, no COS. Clear? Configuration S. Now, if I have to draw the enantiomer of this or optical isomer of this, then I can just say draw the mirror image of this part, okay, and the mirror image will be R configuration. Clear? Okay. Find RS configuration in given compounds. Now I am giving you a few questions. You have to find RS configurations. First of all, okay, so students, you have to find RS configuration in these two cases. You find out. I am writing new questions here. Okay, so I think you must have completed this one. Let's see one by one. First, this one. See, if I'll see for this carbon CHOH, CH2OH and OH, so it is chiral center. This oxygen, carbon, carbon and H. So this is first priority. Now come to this one. This carbon is having 2 hydrogens and 1 oxygen. And if I see this one, it is having carbon double bonded with oxygen. So simply this will be more priority. Okay, 2. Then this is 3 and this is 4. I have to simply move 1 to 2. Okay, so this is anti-clockwise S, but here it is hydrogen, so it will be R. Clear? Why I made R in spite of anti-clockwise? Because hydrogen lowest priority in horizontal. Clear? Keep this thing in mind. Most of the times you make this mistake only. Now see this one. COOH and this is C double bond O and H. OCS3. Obviously this is oxygen, carbon, carbon and oxygen. Now carbon common. Now H, it is carbon. So this will be high preferred group. So this is 1, this is 2. Now question arises, what about these two? So let me check their hypothetical part. Okay, if I see about COOH, then I can simply say here C double bond O OH is similar to COH double bond O means simply oxygen. This oxygen is connected with carbon and this carbon is connected with oxygen. See, this is hypothetical. Okay, C double bond O. So I connected when single bond. Oxygen is connected with another carbon and carbon is connected with another oxygen. Clear? Now again, C double bond OH. This will be CH. Now this oxygen connected with 2 carbon and carbon connected with 2 oxygen. Now let's see this one. So if you have done it correctly, then you will find that here this is carbon, this carbon is having OOH. This carbon is also having OOO, 3 oxygens. So this is more preferred, 3, and this will be your 4th. Okay, this is your priority number 3. So now you can simply say here it is your clockwise. Okay, also 4th priority in vertical line. So I can say here that it is clockwise, configuration will be R. Okay, clear. Now let's come to this one. If I check this part, I can simply say that in this question, this is having bromine, chlorine, carbon and carbon. So bromine will be obviously 1, chlorine is 2. Now carbon, carbon is common, here it is oxygen. Okay, Now for oxygen I can say this will be 3 and this is your 4. Okay, so dear students, here you can see 3 and 4 coming to 2, you have to cross fourth one, so it is simply clockwise, and lowest parity group on vertical, so the same will be the answer. Clockwise means R configuration. Okay, now let's see what about this one. Hydrogen, deuterium and carbon. So carbon is preferred. Now in carbon also, if I say which one will be preferred, so in carbon C12 and C14, so C14 is preferred. Okay, so this is 1, this is 2, this is 3 and this is 4. So it is anti-clockwise, but at the same time lowest priority group on horizontal. So anti-clockwise will be S, but it will be R. Okay, clear? Note down all the cases and you can solve a few questions by yourself. Just practice such cases, keeping yourself making new questions like C double bond C, C triple bond C, and try by yourself. Okay. Find RS. Now we have understood how to check RS configuration in all the cases. Clear? Now let's see a few different things about RS configuration. Okay, let's learn one by one. First of all, okay, now find RS configuration in this molecule. Okay, let's see. See, here you are having chlorine, here it is carbon, here it is carbon and hydrogen. So for this chiral center, this will be preferred as first of preference, chlorine. Now this carbon and this carbon is common, but on moving we have hydrogen, chlorine and carbon. Here it is C double bond O and O, means 3 oxygens you can see. But here 3 oxygen, but here 1 chlorine. So chlorine is preferred. So this side will be first priority, means 1 and 2. So it will be clockwise. Clockwise means R, but hydrogen is here. So it will be S configuration. Okay. Now what happens? See, if I say numbering, IUPAC numbering 1, 2, 3, 4, 5. So students, sometimes you are given to check RS configuration with IUPAC name of the compound. Okay, find the configurations across 2, 3 and 4 number carbon atoms. So you can see 2s. Okay, again I am telling chlorine is first, then this part will be second. So clockwise means R, but hydrogen is in horizontal, so reverse S. Now check this one. Okay, let me tell you one more thing here. Check this one first. Bromine. So bromine will be preferred first, then this part carbon common, but here chlorine and carbon, here is CS3. So this part is preferred. So it is anti-clockwise. Okay, so anti-clockwise means S, but hydrogen in horizontal, so R. So 4 is R configuration. Clear? Now let's check third one. Now what happens here? Sometimes a mistake occurs that this is S configuration, this is R configuration. What to do? See, you have nothing to do about R or S configuration. You have to check the groups, which group is different or which group is same. From this you are having chlorine, hydrogen. From this carbon common. Here you are having chlorine, carbon, hydrogen. Here you are bromine. Simply if you get one of the atom having high priority, then it is done. So from this chlorine is 1, this part is 2. So simply this is clockwise R, but hydrogen is here, so reverse S. So you can say it is 2S, 3S, 4R. Okay, clear to everyone? Now I am telling you one more thing. Okay, now find out RS configuration in this molecule. See, chlorine will be first, here this part, carbon with chlorine second. So clockwise, reverse anti-clockwise. This is 1 2 3 4 5. See, in this question I am teaching you a very important concept. Okay, so 1 2 3 4 5. So you can see here, this will be having 1 2 clockwise, this will be S. Now let's check third one. Now here, if you will see third one, you will find that this carbon is having HClCOH. Here also HClCOH. Now you may think that third carbon is not having two different groups on two sides. Okay, yes, that is correct. So let's do one thing. Find the configuration across R, this fourth one. Chlorine 1, this side will be 2. It is clockwise and horizontal here, reverse anti-clockwise. So it is S. Yes. Simply you can see that in this question, second carbon is having configuration S, fourth is also having S configuration, and at the same time this entire portion and this entire portion is same. So we can say that in this question third carbon is not chiral. Okay, means here the chiral center in this particular case is second and fourth. Clear? Now let me draw, it's one of the isomer. So suppose if I draw one of the case of the same compound COH, only interchanging this part H and Cl, keeping all the parts same, Cl, Cl, H, H, and this is your COH. Now numbering from same 1 2 3 4 5. Now you can see RS configuration here. See, chlorine this side clock, reverse anti-clockwise, S, 2S common. Now third I don't know, fourth let's see, chlorine will be 1, here carbon Cl, here carbon oxygen, so this will be preferred. So anti-clockwise, but hydrogen in horizontal, so reverse clockwise. Now students, let's see that in this particular case, here this carbon was not behaving as a chiral center. Why? Because at second S configuration, at fourth S configuration, and this entire portion was same. Now here also for third carbon, this entire portion and this entire upside portion is same, but the configuration across second carbon and fourth carbon is different. Means if we say about ppl rotation across S and R, so as the carbon, this part for this and this part for this is same, so the direction will be different, magnitude will be same, but from that portion also we can say that R is different and S is different. So we can understood here, we can assume preference order, R is preferred over S. Keep this thing in mind. So here we can say third carbon as a chiral center. Okay, why? Because here this part group wise it is same, but configuration wise it is different. Okay, so preference order will be R preferred over S. Similarly, if I say cis and trans case, cis preferred over trans. Okay, also Z preferred over E. Keep this thing in mind. R greater than S, cis greater than trans, Z greater than E. Priority order, okay, in such cases. Now, let's see. From third carbon, chlorine is 1, this downside is 2. So, clockwise means R, but hydrogen in horizontal, so reverse S. So, third part will be S. Now, students, here question arises, sir, from this structure, the carbon was not chiral at third, C3. And here, C3 we have given the configuration, assuming it as chiral. So, what do we say to such a carbon atom? So, understand this C3 is called as pseudo chiral carbon. Okay. Now again I am telling one new name. I have already discussed about chiral carbon, pro-chiral carbon. Now I am telling you about pseudo-chiral carbon. Here P is silent. Pseudo-chiral carbon means a carbon atom which is chiral in one structure but which behaves as achiral in the another structure. Okay, means in this structure C3 here acts as achiral, and here if we see C3 acts as chiral. Okay, so in one case it is behaving as achiral because both the groups along with configuration similar, and here that same is having same group but configuration different, so chiral. So such a carbon in one form chiral part as a chiral carbon and in another structure as a achiral, such carbon atom is called as pseudo chiral carbon. Clear to everyone? Okay, keep this thing in mind, write down the definition. I hope you must have noted it down. Okay, pseudo chiral carbon, you can say carbon atom which behaves as chiral in one isomer but as an achiral in another isomer of same compound is called as pseudo chiral carbon. Okay, clear? Carbon atom which behaves as chiral in one isomer but as an achiral in another isomer of same compound is called as pseudo chiral carbon. Now important part for this pseudo chiral carbon is it is always considered as a chiral center. Now why I am using this point? Because whenever we need to calculate the total number of stereoisomers or total number of optical isomers, then we need to think whether we have to consider it as chiral or not. So remember this point, it is always considered as a chiral center, especially for calculating total number of stereo isomers. Okay, clear to you all? I think you must have noted and I have given you an example clearly. Okay, find RS configuration in. Now hydrogen, deuterium, methyl, and this is suppose bromine. Okay, so students, here I am giving you one more concept. When we are given with dash position lowest priority group, then we can simply define RS configuration in wedge dash formula. Okay, why? Because lowest priority group lies at away from the observer. So using CIP rule for RS we can define it. Just like here, if I say priority order will be bromine 1, this is 2, this is 3, simply I can say it is clockwise, so the configuration is R. Okay, but now the question arises, what will happen if lowest priority group is not given in dash position? What will happen? So we have two cases here. Understand, I am telling you two different cases. Okay, first one is even interchange gives identical, odd interchange gives enantiomer. Now these two is based on across a chiral center, across a chiral center. You can better to say across any chiral center. Okay, and that is not a chiral, that is a chiral, any chiral center. Clear? Now let's see this one. I am telling even interchange. What does it mean? So simply means that suppose if I keep this part as same, fixed, okay. Now if I rotate first of all hydrogen and deuterium, this interchange, one interchange. Now again one interchange of this bromine with hydrogen, this, such that two interchange occurs, keeping one part as a fixed, freezed. Then you will get same molecule, okay, identical. You, in terms of configuration I am saying, means in every terms you will find identical molecule, okay. Now if you make either one interchange or three interchange or five interchange, means odd number of interchange, you will get enantiomer, okay. So across any chiral center, if you make 2, 4, 6 even number of interchange, you will get identical molecule, and if you make odd number of change, you will get enantiomers. Clear? Note it down. I will give you now one example. See, this is one of the case, one part, okay. Noted? Now second criteria, convert wedge dash form into Fischer form, okay. Now I am teaching you how to convert wedge dash form into Fischer form. Clear? Understand it very well. Now look at this compound. Carbon is having chiral center FClBri, okay. Now the question arises in mind, if we convert this wedge dash formula into Fischer, what will happen with its configuration? So remember, you can convert, there are many ways to convert wedge dash into Fischer, okay. In many ways it has been taught, you will find in many ways, but remember one most important part, you convert wedge dash into Fischer or Fischer into any another form, but configuration must be same, then only you can say that the conversion you have made is perfect, otherwise that is wrong, okay. Now let me tell you the rules first. Rules, okay. So first rule is, place wedge group at the top of Fischer. Second, dash group at the bottom of Fischer. Clear? Wedge group at the top of Fischer. So here we are having one carbon atom. So let's draw Fischer. Wedge group at the top, so Cl will be at the top, okay. Dash group at the bottom means fluorine at the bottom. Clear? Now with respect to group at wedge, two remaining groups are placed in clockwise anti-clockwise direction, means with respect to group at wedge, means with respect to this chlorine atom, two remaining groups are placed. Which two remaining groups? This bromine and iodine, in clockwise and anti-clockwise direction, in its clockwise and anti-clockwise direction, as they are in wedge dash form. Okay, means the way they are given in wedge dash form, in the same way place the two remaining groups. Means if I see this compound, chlorine at the top, fluorine at the bottom, wedge dash. Now with respect to this chlorine, bromine here clockwise, so bromine here clockwise, and iodine here anti-clockwise, so iodine here anti-clockwise. Clear to everyone? See, this is one of the most important conversion I am teaching you. Okay, now the question arises whether these two are perfect or not. If you have to check that, sir, if I have made this conversion, interconversion in one form into another, it is correct or not. So let's check RS configuration. If RS in this and in this it is correct, then you can simply say that your interconversion is perfect. So let's check it. Priority wise, iodine 1, bromine 2, so it is your anti-clockwise, and here lowest priority, that's why I used here lowest priority group at dash position. Okay, so anti-clockwise rotation, dash position, it is S configuration. Clear? Now let's check here. Iodine 1, bromine 2, chlorine 3, and fluorine is 4. As you know, we can cross fourth one here, so it is anti-clockwise, configuration will be S, but lowest priority on vertical, so S will be S only. So you can see our interconversion is perfect. Clear to everyone? Again I am repeating. First of all, in wedge dash configuration, wedge part at the top of fissure, dash part at the bottom of fissure. Now with respect to wedge part, you have two remaining groups. One is towards clockwise, one is towards anti-clockwise. So in the fissure form as well, with respect to top portion, place one part into clockwise, one part into anti-clockwise, and you will get the identical molecules. Clear? Okay. So note it down perfectly. Now the question is, convert wedge dash into fissure projection. Okay, if you will use the simple strategy I have told, you can make it very easily. First, okay, so you have to convert these two into fissure form. Okay, do it first yourself. Okay, let's see. See, if you remember, I am using the same compound again. It is 1, 2, 3, 4. It is 2-butanol or butane 2-ol. It is also 1, 2, 3, 4, 2-butanol. Okay. So, wedge at the top, dash at the bottom. Now, with respect to wedge, this ethyl is clockwise. So, ethyl here, and this methyl is anti-clockwise. So, methyl here. Okay. So this part is converted like this. Clear? Now check this one. Wedge at the top, dash at the bottom. Now with respect to wedge, anti-clockwise is methyl, anti-clockwise is methyl, and clockwise is, sorry, anti-clockwise is ethyl here. And clockwise is methyl. Okay, clear? Now again I am telling, check it using RS configuration. If you find this one and this one correct, then your interconversion is perfect. So let's check RS configuration here. If I'll check this one, then oxygen will be preferred than this one. So it is simply clockwise. So for clockwise rotation, it will be having configuration R. Okay. Now this one, OH and this, it is simply anti-clockwise. So it is S. See, if I will say a relation between 1 and 2, they are what? They are enantiomers. Okay. So it is an enantiomeric pair. Now check this one. OH is 1, ethyl is 2. So it is simply clockwise. So R and C, hydrogen in vertical only. So it is R. Now check. This is R, this is also R. So interconversion is perfect. Now check this one. This is having S configuration. Now check this one. OH1 ethyl 2. So it is anti-clockwise and hydrogen at vertical. So the same. It is having S configuration. Clear to everyone? Okay. So you can see R, R same, S, S same. So the interconversion part is clear to all of you. I can understand. Okay. Done. Now if I say relation between 1 and 2, or if I say relation between this and this, then I can simply say they are enantiomer of each other, right? Now how it is enantiomer of each other? See, if I place mirror here, what will happen? OH and H will remain same. See, OH and H remain same. This methyl and ethyl will be interconverted. You can see ethyl and methyl is interconverted. Okay. So they are enantiomer of each other. Clear? Relation between 1 and 2. Here 1 and 2 are enantiomers of each other. Clear? Also I told this first and second, same thing. Mirror image of first will be second. How? See, again I am repeating that part. I told one more way, right? Even interchange and odd interchange. You can see here what I did. In this molecule, if I see, I have just rotated one part, one interchange. This methyl and ethyl interchange. Rest remaining part is all same. So you can see OH and H is same. Just the interconversion of methyl and ethyl. Okay, and you can see you are getting enantiomer. So even interchange, it is odd interchange. Odd interchange gives you enantiomer. Clear? Okay. See, we have this compound and we have to check whether given structure represents same compound or enantiomer. Okay, now you are given one wedge dash form and also you are given one Fisher form. Okay, now you have many ways to check this one. Okay, I am telling all the ways here. So you can use any of the way in the examination. Now one simple way is just check RS in this compound. Here you are having bromine, chlorine, oxygen. So it is 1, 2, 3. So this will be like this, clockwise, and hydrogen in vertical. So same. Clockwise means R configuration. Okay. Now the question is, here lowest priority group is not in dash form. Lowest priority group is not away from the observer. Now I am using here one concept. Which concept? Keeping one part fixed. I am rotating the remaining part once. Okay, means even interchange. So if I say keeping this part fixed, okay, just rotate this part. So what will happen? Now see, I have to make hydrogen in dash. So I will just, what I will do, this will rotate this side, this will come this side, and this will come this side. So rotation in any direction, clockwise or anti-clockwise, that will give you same compound. How same compound? You can see what you will find here. Carbon with dash position with hydrogen, bromine as it is, this will OH, and this will be Cl. Now you can check dash position for hydrogen. How? What we have done? First you interchange H and OH. So hydrogen will be here, bromine as it is, and OH will come here. Then interchange OH and Cl. So we'll get Cl here and OH here. This is even interchange. So here you have obtained same compound. Okay. Now check RS in this. RS configuration in this one. So bromine 1, chlorine 2, OH 3. So you can say this side, clockwise rotation. So this is having configuration R. Now this is having configuration R. This is also having configuration R. So the given compound were identical. Okay. Now this is one of the technique I used. Again I am repeating. What you have to do? Freeze one part. Okay. To bring the lowest priority group on dash position, means away from the observer, freeze one part and rotate in either of the direction, clockwise or anti-clockwise, in such a way that you get lowest priority group on dash. So by rotating this in this side, I am getting this part. Clear to everyone? Okay, so this is R identical. Now you must have question, sir, why don't you just convert this into Fisher in the way I discussed earlier and then check it? Okay, so let's do that one also. I am converting this into Fisher. Okay, what I have to do? Draw the Fisher. Wedge position at the top, dash position at the bottom. With respect to wedge, clockwise is Cl, anti-clockwise is Br. Okay, now you have to find RS in this one. So bromine is 1, chlorine is 2, OH is 3. You can see it is clockwise. So if it is clockwise and lowest priority group on vertical line, so you can say it is having configuration R. So guys, you can see using this method or this method, we are getting same. Means both the methods are applicable. You can use any one of it as per your suitability and comfortability. Okay, the way you are comfortable. This method or this method, configuration is R here, here also R. Now the question was, check whether given structure, this structure and this structure represent same compound or enantiomer, as it is having configuration R and this is also having configuration R. So we can say they are identical. Okay, clear to everyone? I think you must have understood the method of interconversion, how to bring lowest priority group on dash position, right? Now you can use this method also. Okay. Okay, so in this question, if in such questions you are asked to check RS configuration, configuration of each chiral center in the given compound, first you have to check how many chiral centers are present in this compound. Okay, so you can see with this carbon you are having HCl, this and this group, so it is chiral. So first of all you have to do IUPAC naming. See, remember what happens most of the times, you mistake due to numbering. What happens here? If this is given, our general method of using is name it 1, 2, 3, 4 like that. But here you have to see 2, 3, 4, 5. Here also 2, 3, 4, 5. That is common. But here you are getting 2 bromo, 3, 4, 5 trichloro. And here you are having 1, 2, 3, 4, 5, 5 bromo. See, alphabetically bromo and chloro. Bromo comes first. So you have to use bromo first. Okay. So numbering actually will be 1, 2, 3, 4, 5, 6. Now first mistake is corrected. Okay, now next part, across second. First of all, bromine will be first, then second, clockwise R, but hydrogen here, so it will be S, 2S. Now check this one, chlorine first. Now this carbon and carbon common, here Br, here Cl, so this will be preferred. Chlorine So it is anti-clockwise, but hydrogen here, so clockwise. So third is R. Now check this one. See, across this chlorine and hydrogen, this part and this part. So this part is having HCl, CS3. This part is having HCl, not CS3, but carbon with HBr. So this part is preferred. So from this chlorine, anti-clockwise, hydrogen here, so reverse, R. Now last this one, chlorine 1, downside will be 2. Anti-clockwise, reverse, R. Clear? I think everyone has understood. Again I am repeating. Let's see from this one. Chlorine first, this one. Anti-clockwise. Anti-clockwise, S, but hydrogen in horizontal, so R. Chlorine 1, then down part will be high priority. So again S, but reverse, R. Chlorine 1, this downside will be high priority. Why? Here you are having bromine, here you are having chlorine. So chlorine, anti-clockwise, but hydrogen here, so reverse, clockwise, R. Bromine, then upside, clockwise, reverse, anti-clockwise, S. Okay, so this is having R, 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 S. So if I say the IPSC naming of this compound will be 2S, 3R, 4R, 5R, 2-bromo, 3,4,5, trichloro-pentane. Clear? So remember this logic, okay? Okay, now I am giving you a few examples. Here you have to check a relation between the given compounds. Now relation means what? Either they will be same, identical, or they will be enantiomers. Okay. Okay, so you have to find relation between 1, 2, 3, 4 and 5. See, in all the cases I have used one chiral center carbon having fluorine, chlorine, bromine and iodine. Okay, now find out. I am giving you hint. You have two possibilities. One possibility is just to check by even and odd interchange. Even and odd interchange means by one interchange, if you are getting the same compound, then it is enantiomer. By two interchange, if you are getting the same, then it is identical. Three interchange and you are getting the similar, then it is 3 odd, so enantiomer. And 4 even interchange, then identical. One option. Second option, in such cases the easier method will be check RS configuration in all 5. RS configuration. If RS configuration in all these are same, then they are all identical. One is R, another is S. They are enantiomer of each other. Very simple. So let's find RS configuration. Then I will check this one again in terms of odd or even interchange. Okay, so we'll be very clear how to check in both the ways. So first of all, let me find out here in terms of RS. So here iodine is 1, bromine is 2. So it will be anti-clockwise rotation, and fluorine here. Okay, so what will happen? It will be configuration S. Clear? Now check this one. Iodine towards bromine. So it is anti-clockwise. Okay, but fluorine here. So reverse. It is R. Now you can simply see first and second are enantiomer of each other. Now check third one. Iodine to bromine. It is now anti-clockwise and fluorine is here only. So it is S. So you can see first and third identical. Now check fourth. Iodine towards bromine. Now question is from which side? Iodine towards bromine from fluorine, this side. So clockwise and fluorine here only. So it is R. Done. Now last. Iodine towards bromine. but fluorine in horizontal. So anti-clockwise, S, reverse, it is R. Now, using RS configuration, what I can see is first and third identical, second, fourth and fifth identical, okay? So I can say 1, 3, okay, 1, 3 identical, 2, 4, 5 identical, because 2, 4, 5 having same configuration, one chiral center, same molecular formula. Now, relation between any of these two with any of these three will give you enantiomer, okay? Relation between 1 or 3 with 2 or 4 or 5 gives enantiomer. Now the relation between 1 or 3 with 2 or 4 or 5 is enantiomer. Clear? Okay. Now I am expressing this same part in terms of odd and even interchange, because that is used in examination to check very quickly. Here I have given 5 questions, but when you are given just 2 questions, you can check it very easily. Now see, if I have to check first and second, see, you can start from anywhere, okay? Now let me start. I have to make this one just similar to first one. So here iodine in this position. So first interchange iodine and bromine, okay? So iodine comes here, bromine comes here. This is first interchange. Now I have to bring bromine here. So bromine will come here and chlorine goes there. Second interchange. Now chlorine from here to here. Third interchange. 3 interchange means odd interchange in enantiomer, you can see, okay? Now let me say first and fourth. Iodine same position, you have to do nothing. First interchange bromine and chlorine. Bromine and chlorine. One time interchange. Okay. See, I have to make this one similar to this one. Now I am doing interchange here. Iodine as it is. Now here it is bromine. So first interchange these two. So bromine will come here and chlorine will come here. Now you can see identical from one interchange. So first to fourth. 1 to 4 interchange. How many interchange? One interchange. So you can see it is enantiomer. Now if I say structure 1 to second, how many interchange? I said bring iodine here, first interchange. Bromine comes here. Then bromine comes here, second interchange. Then chlorine will go there. Then chlorine comes here, 3 interchange. So you can again see it is odd interchange enantiomer. In the same way, you can check other ways also. Other part. 1 with 2, 1 with 3, 1 with 5. Okay, clear? So I think students, you are very clear with all the topics covered in this video lecture. See, I have mentioned you about how to check RS configuration in wedge dash formula. In all those cases, whether the lowest priority group lies at away from the observer or not, means lowest priority group may be in maybe in dash position or any other position. You can find out very easily in wedge dash only, or you can convert it into Fisher projection, then you can find it out. Okay, I have mentioned you about conversion of wedge dash into Fisher. Clear? Again, I mentioned you about pseudo chiral center, which is chiral in one and not chiral in another. So it is very clear to all. We will continue in our next lecture. Okay.